Hey folks, welcome along to this video where I'm going to break down how not to set up an AWS RDS Aurora serverless v2 instance and not rack up a $2,000 bill. So in this video, I'm going to break down what I did wrong. What did AWS say? Did they actually, discount the bill or make us pay everything? So let's crack on and find out how I actually incurred a $2,000 bill using Aurora Serverless v2. Let's crack on and actually find out or dig a bit deeper into my horror story of racking up about $2,000 worth of compute on AWS using Aurora Serverless v2. But a bit of housekeeping. Firstly, who am I? My name is Amogelang Moloko. I'm a full stack engineer. I work at Naked Insurance. We're one of South Africa's first digital native insurers. So I work on the claims team at the moment using all things AWS, and mostly in TypeScript and sprinkle a tiny bit of Gen AI when the need arises, or it's actually a lot. Tiny is a bit of an understatement at the moment, but yeah, we're doing some fascinating things with Gen AI, and yeah, makes it super exciting to go to work in the morning. And yeah, in a nutshell, a tiny bit about myself. I am extremely startup focused. I've only worked at startups my whole working career, and I've had a bit of experience across e-commerce, logistics, and now insurance. Cool. So now that we've got that out the way, how did this all start? Right. So when I joined Naked, I joined and there was a new greenfield project. Right. So whenever I start a new greenfield project, I'm always thinking, is the time to experiment with something new? Because I feel as a dev, it's in our lifeblood. Or, it's kind of our duty to be experimenting with new tools or whatever, what have you, not just to improve our own developer experience, but see if we can save costs and time and basically help deliver more value for our customers. So I was like, cool, we're going to dig into the DB layer and we are going to try using RDS Aurora serverless for the DB instead of using a regular managed Postgres instance on Aurora, right? So with the AWS TypeScript CDK, it was quite simple to spin up a cluster. In many instances, which I'll show you how I spun up shortly, which is pretty much the source of my downfall in this whole scenario, right? But yeah, cool. Spun up an instance in dev until I racked up that $2,000 ball, all over $2,000, or 2,444 or $2,446 and 0.0 cents. All right. So yeah, pretty painful. So interesting to note that a couple of things, right? That we should note that these instances, firstly, have had zero data in them at the time. In the previous month of September, as you can see in the graph, October is when we incurred the 2,000K, the 2K plus bill. But in September, no issues, but there have been no data inside any of the instances. There were no active connections. And yeah, pretty much no code was written against those instances to maintain any active connection. So this is super strange. And in September, the instances were all spun up. And throughout the whole of September, no issues. I think we had only paid about $300 for them, which should have already been a red flag, but I'll get into that a bit later. Nonetheless, completely surprising message to have gotten just after my stand-up to say, hey, man, what's going on with your Anton, our security expert, was like, yo, dude, what's actually going on with these clusters that you spun up doesn't make any sense. So before we even dive a bit deeper, for those of you that probably don't use AWS or don't use Aurora at all, whatever the case might be, let's actually dig into understanding what it is firstly. So it's AWS's SQL managed service, where basically you can run MySQL workloads, Cassandra, Postgres, SQL Server, and a whole bunch of other SQL related databases, right? But the beauty with Aurora is that obviously it's serverless, so you don't have to manage the clusters or the instances yourself and do all of that heavy lifting. Everything will scale automatically, right? So with that said, it's just an on demand auto scaling configuration for Aurora that, based on your capacity, will scale dynamically. And the way you do that is you set up Aurora capacity units for your reader and writer instances. So you can also configure those instances to be a particular integer value of any kind, right? So with that said, it's important to note that based on the amount of instances you have in your cluster, each instance will be given a minimum ACU, right? And then basically per your region, you'll be billed per ACU per hour, basically. So I think at the moment in EU West, which we run, I think it's about 14 cents. So you basically take the amount of instances you have and the minimum capacity units for each instance, multiplied by the amount of hours that your cluster is on for, multiplied by the capacity unit per hour, should give you the costing for like your forecasted price that you will pay, or sorry, the cost that you'll pay for running that particular instance of Aurora Serverless v2. Cool. So let's dig into where exactly did I mess up? Okay, and quite frankly, where I messed up, like I mentioned earlier, was in my configuration using the CDK. So as you can see in the first red block, yes, you're probably wondering, why did this guy set the minimum capacity unit to 8 and the maximum to 64? It's like, that's asking for trouble, right? That's like telling AWS, give me max power for everything, right? Okay. And then in addition, in the purple block, you can see I've got 2 readers, and one of the readers is meant to scale with the writer. So what ended up happening was that I had 4 separate instances inside this cluster, right? So basically, essentially, you had 4 instances with a minimum capacity, with minimum ACUs at 8. We'll get into the calculation for what that was, but I'm pretty sure the smart ones that are still watching, based on the figure that I showed earlier, you could pretty much break down before I get to the end of the video how much we ended up spending. Cool. So, however, as stupid as I was, as careless as I was, as negligent as I was, remember, there were no active connections. There was no data in the various instances within the cluster. And it was only in one environment, kid you not. It was only in our dev environment, right? In that dev account. So let's dig in. So here we've got a nice breakdown of some of the logs before we did, sorry, not the logs, rather like the CloudWatch insights that I took a screenshot of before deleting the instance, because I thought, okay, cool, we're going to take this and send it off to AWS when we contact support. So as you can see in this little graph on the right hand side over here, you've got the 4 instances, but as you can see that around the 28th or the 29th rather, the capacity units were idling at about 17.4 for at least just one of the instances, and then basically on the 30th it just shot up to 221 essentially. But what's interesting is that it's only saying that it utilized 13.5% of the ACU utilization. So obviously, this led us to believe that, look, I think this correlated what was going on with the billing in the sense that the bill showed that in September, we were paying a large amount, but in comparison to what we paid in October, it was larger. And also bearing in mind what we that this bill that we incurred was actually more is actually comparable to what we're actually paying in production for all of our main databases combined. You know, so with that said, okay, you know, it was quite obvious that something happened that was not within our control. Even though this was a perfect recipe for setting the capacity units to be so high, something is obviously not kosher over here, right? So, but before we get there, I think we can just dig into like how this could have been prevented, and how this could have been prevented was probably understanding the ACUs better and forecasting demand, and then alerting and focusing on alerts and monitoring as well. So let's first go through the ACUs, right? So as you probably can gather, that essentially it's not entirely serverless, right? Because the instances still need to function at a minimum capacity, so they will idle at whatever you've set your minimum ACU to be at, right? So in my case, it was 8. So you had 3 or 4 instances at a given time idling at 8 ACUs, basically for well over 30 days in the month of October. In addition to that, monitoring and updates contribute to ACU usage. Okay. And I was just way too adventurous and generous and probably careless in the dev environment, So I would not be surprised if this bull, no, I doubt. I was going to say, I wouldn't be surprised if this bull contributed to Jeff Bezos buying a brand new yacht or whatever the case, but I'm pretty sure he's getting his cash. AWS is getting his cash from other customers that have more intensive workloads than this little instance. Cool. So another thing that happened that I did not do was forecast demand and cost effectively. So what I have here is a screenshot of the pricing calculator, the cost calculator from AWS. And geez, I think since this incident, every new thing that I make on AWS, I always just go to, even if it's like something as simple as S3, I just go to the pricing calculator just to make sure. And this pricing calculator actually helps in the sense that it puts your mind in a state of actually thinking about the problem, not just from like, cool, I need to get this feature out, whatever the case might be, but like, you're putting the interests of the business at heart as well, to make sure that you are actually aware of the cost, and that potentially, to meet particular demands, that this is how much your solution might actually cost the company. And then, you actually go through a whole scenario of, cool, how can we change how we want to build things to optimize on cost? Okay, and this is available for every single AWS. This is available for every single AWS service. Okay, and then in terms of forecasting demand and cost, one thing I should have done, which would have been pretty simple to do, should have been to essentially just compare the price of the smallest Postgres managed configuration on Aurora, which you can see there, it's about $99 a month. And then if I had just played it around in the costing calculator and set the max capacity unit to 1 or 2, you can see that the costing is actually a lot more expensive, than not by that much. I mean, if my maximum capacity unit was 1, there's about a $2 to $3 difference. But if I increase my maximum capacity unit to about 2, that's like $309. You know what I'm trying to say? So then this would have posed a question to people in the team, or not, sorry, would have invited more feedback and criticism from people in the team to be like, cool, are we just happy, making a new deployment and upgrading the configuration on the whim ourselves, as opposed to getting AWS to manage this for us, right? And another way I should have also actually forecasted cost is, usually sometimes for a particular service, there will be like a goal of like it will be tied to a financial goal, right? So say for argument's sake, you an e-commerce company, and in your checkout flow, you're saying you want 10% of, or maybe 10 or 20% of customers to complete payments via crypto, for argument's sake. And you build in a new crypto integration or whatever the case might be. But before starting that, a wise thing would be to actually obviously first analyze, cool, what are the current number of payments that are being made on the site. And let's say for argument's sake, it's 100. We're just going to work at like small numbers. Let's say it's, it's 100 of the total, let's say you get 100 payments a month. So it's a pretty small e-commerce site that you're running. You get 100 payments a month, and then out of those 100, you only want 10, 20 or 10% to be done via crypto, right? So then you can then configure your infra and your traffic, or use that value to infer and assume and forecast that, okay, cool, we're only expecting 10% of those users to be running through 10% of the 100, which is like 10, to be running through this new feature for paying for their goods via crypto. Then you can then go and see, okay, cool, based on those number of users that I forecasted, at the beginning, then you don't have to be so generous with the capacity units, and then you can pick the right service based on the price. And that's like at least decent forecasting, unlike what I didn't do at all, So that's what I should have done at the beginning. Cool. In addition to that, we didn't set up alerts, right? We didn't set up any alerts for when, at least, in September, we should have set up like a $50 alert or $20 alert, which would have let us know that, hey, dude, you guys are paying way too much for nothing, for no data, no active connections. So since that, I think every new service that we've been setting up, and also retroactively, we've been going through all the other services, and we've been using Terraform to set up automated budgets, which you can also do in the console as well, which is quite simple. And then, takes what you want to forecast versus what you want to budget for. And then you have a threshold, and then I can send you an email or an alert into Slack to let everybody know that, hey, cool, this particular service is above its threshold. Please go take a look, or take whatever action, because in this case, we were not aware at all. Okay. So now, what did AWS actually say in this whole fiasco, right? So we contacted support like you would normally do, and we sent them a message. And essentially, their first hypothesis was that this could be due to increased storage utilization, and a common use case that they thought maybe is that there's an inactive replication slot, and when it's not consumed, when that replication slot is basically not used, it rapidly consumes storage space on the database, and then maintenance and any statistical updates can cause temporary resource spikes, which is definitely what happened. Because in addition to this, after we got this message, we hopped on a call with some of the RDS team here in Cape Town, and the one engineer basically said, based on the information that we gave him, we had, essentially the likelihood of it being due to maintenance or any updates or any monitoring is definitely could be definitely the root cause of why the resources just spiked to such astronomical levels. In addition to having those generous ACUs set up in a development environment. And in addition to that, for fun, they linked us with the blog post to how you can reduce your Aurora Postgres storage IO costs. Okay, so after we had that interaction with the regular support team, I think they forwarded our case to the RDS team, who had additional logs of what happened on our cluster, because we had deleted everything in a hurry as well. So essentially, what they said is essentially, cool. We charge 14 cents per ACU hour, and approximately the active time in October was 2,181. Minimum configuration of 8 ACUs, which resulted in 17,448 ACU hours, which aligns with what happened in the billing. And essentially, ACUs are billed irregardless of active connections. So as you can see here, that this is not really it's not like DynamoDB or Lambda, where it's just going to really actively only spin up once you start using it. And even such, like, word on the street is that a lot of folks, a lot of companies that have like high volumes of traffic, talking like probably well over like 20 million invocations a day, are paying a lot of money for using Lambda as well. So I think I've been a big proponent of serverless over the years, but yeah, once you get to a particular scale, I think not just in like serverless compute, in most systems as well, you're gonna pay a lot. So like, take for something like, let's say you started a startup, and in your startup, like, Zapier is like a key part of your workflow, or whatever the case. But like, once you're starting out, $500 a month seems like nothing. But then once you get to a particular scale and you're reaching the pricing page, and it's like, contact enterprise support, and I can only give you like a 2% discount or a 5% discount, and you're paying basically like 3 people's salaries to this provider. It gets pretty, it gets pretty expensive, right? But obviously, your database and your API layer is something different. So it's a key component of your system. So you might look to the side. However, still pretty expensive. And their advice basically was essentially, yeah, dude, they put it quite politely that maybe reduce the consider lowering the minimum ACU to 0.5 for our workload. So another thing I wanted to mention as well is that I was kind of disappointed in AWS's handling of the situation. Reason being, yes, I totally made a massive error, but in the past, they've been usually quite generous and open in terms of like reducing the bill, at least, or even waiving bills when it's like a clear customer error. And like, also in this case, yes, it was an error where I made the minimum ACU 8 and the maximum 64, or what have you, for dev environment. But I mean, it was quite clear that there was no active connection. If there were like still people using the thing in dev, then they'll be like, yeah, but look, okay, cool. You gotta learn the hard way, right? However, yeah, AWS did not waive the bill or offer any discount at all, which is left a sour taste in the mouth, and it was tough, very very tough pill to swallow. Okay, but what does provide me with a bit of comfort? I know that sounds a bit evil and like um, negating or not taking any responsibility for the big error I made. No, no, not at all. But what did help was that I just had to look around the internet and know that you know mistakes are part of human nature. That's what makes us. That's what makes us human. Nobody does not make mistakes, right? So first up is the Hubble telescope. So when the Hubble telescope was launched in 1990, it actually was shit blind. Funny enough, the images that were coming back were too blurry. You couldn't make out anything. Essentially, what happened is that they misconfigured the one of the mirrors, essentially, that helped with taking pictures. So I have no clue how this discipline of engineering works, so I'm not even going to bother to try to explain the science behind why the mirror turned Hubble blind, whatever. But basically, they shipped a telescope up, with taxpayers' money. They couldn't see. Took a couple more years to fix up on another service mission. And yes, this is NASA and all of its contractors and suppliers and everybody that were held accountable and were responsible for Hubble. But nonetheless, they learned from their mistakes, shipped it up on a new service mission, and I think Hubble only got replaced by the James Webb Telescope like after COVID or like sometime around then. So it's been functioning for well over 30 years or so. Next up is Quora. So Quora is a social network for artists where they post their work and they connect with other artists or whatever the case. So Quora was pumping so hard that it shot up into the App Store as well on the App Store charts. However, the founders behind Quora used Vercel functions, serverless functions, and they racked up a bill of $96,280 essentially. So they've exceeded whatever their monthly budget was, or whatever the case might be, and now they woke up with the bill. So what happened is, I'm pretty sure if you've tried to learn about Next.js, you've probably watched a video or read a blog post by Lee Robson, and essentially they hit like 500k users pretty fast. Their Vercel's system sent them 12 notifications, which were ignored, and they tried to connect with them on about the 3rd of June. This tweet was tweeted out about the 6th, so like 3 days later, he actually tried to reach out to them. And essentially, they got sent 12 notifications and they had 56 million function invocations per day when the app was rising in the App Store. And they did not have the spend management enabled on their account. So similar situation to myself, where I suspect there wasn't enough time spent on actually understanding, cool, if this thing does take off, those 56 million invocations, surely there's another pattern for that, like what data are those customers accessing? Or is that just purely people using the application legitimately, is what I'm trying to say. Because obviously when you're starting up, you're trying to balance, time spent engineering things and going to market and acquiring customers. So if those 56 million invocations are like legitimate customers just doing basic things like logging in, signing up, scrolling, posting photos, and connecting with people on the platform, then that's a different story. But I mean, if people are fetching the same requests and data, then some caching strategies might need to be implemented. Nonetheless, another thing that was similar to, or another aspect of this Quora case study that was similar to my own, is that at least they had alerts, but in this case, those alerts are not even being read, you know? So this situation is like, whew, yeah, it's a tough one because if they were sent 12 notifications, So I would be keen to find out like what the founders or the technical team were thinking at the time when they missed those 12 notifications, or they were just super busy and locked in. Unfortunately, I don't know how this whole issue got resolved. I'm pretty sure this got taken offline into the DM. So if anybody does know, pop the outcome in the comments. But I mean, yeah, this was like all of close to over a year ago. Cool. Lastly, we've got Netlify. So this developer over here racked up a bill of $104,500. Okay, so geez, yeah, that's a lot. That is a lot, right? And what were they doing, right? So essentially, they hosted a song on their website by a popular Taiwanese singer, and they incurred about like 164 terabytes worth of bandwidth over the course of 30 days, right? And Netlify noticed that most of the device traffic was coming from iPads or Windows 6 machines or whatever have you, or on Windows 98. So it was most likely a DDoS attack. Okay. And immediately they were like, cool, dude, next time use YouTube or Bandcamp or SoundCloud or whatever the case to offload the bandwidth to another platform. And what was quite nice is that in this case they did discount the bill. They do have a discount policy of about 20%, but I think when this email was taken, they only discounted to about 5%. So yeah, still a lot of money. still a lot of money for them. And in this case, it was another similar situation to myself where, forecasting demand, understanding, cool. Well, the thing is, it's very easy with these cases to look from the inside, looking out from the outside into the inside of whatever the situation was, and not really knowing the facts. What were the business motivations? Like, I have none of that, so you can only draw on all of these conclusions, which is a bit unfair, on them. But like I had mentioned, nothing different from what I experienced. Okay, cool, folks. So that brings us to the end of this little TED talk. And yeah, I hope you've learned a bit about how RDS Aurora Serverless V2 works. And also I hope my pain and my experience will help you, not just only with AWS related issues, but just like, how I think all of us think we're quite smart, and, to be a software developer, you have to at least show some level of competency, So I do hope that, this is just a nice little reminder and a warning to anybody of all skill levels that you're never too far away from a massive blunder and catastrophe. And I think it's very important to stay humble, consult widely with other people, especially people in your team. And yeah, like you saw there, especially with cloud computing resources, budget and forecast, really understand your use case, as well as having some form of alerting and monitoring goes really, really a long way. And then lastly, before I close, I just want to give a big shout out to the leadership team at Naked, because I honestly did not expect the situation to be dealt with the way it was internally. So we have a very like flattish organizational structure. So obviously everybody in the company knew what happened, but there wasn't like I wasn't hung out to dry or made an example of, or like given a talking to. Essentially, I was just brought in to explain my thinking and understand why I did what I did, and I think the important thing there was just to be honest about everything as well. So I was extremely honest in terms of just admitting that, look, you know what? It was a massive oversight on my part, especially since I was so new as well, since I just started the job as well. So, yeah. So on one side, super presently surprised and appreciative of the leadership from Alex, Jade, and Anton to just basically yeah. Basically handling it quite professionally, quite elegantly, and then also I don't think any trust was taken away from me or responsibility was taken away from me after the incident as well. So everything still stayed same. Obviously, naturally as humans, if someone does something wrong, you that scenario or situation will always be carried with you. But I mean, that's just normal. But in terms of how the whole situation was handled was tops. Definitely, my opinion of everybody is like only just increased as well. And yeah, like I said, it would have been very easy for me to lie and cover things up, but I think it just doesn't help in this case. And yeah, certainly a massive learning experience for myself. Yeah. So with that said, this brings us to the end of this video. I've got one favor to ask of you. If you like this video, it costs you absolutely nothing. Will only take you literally 2 seconds. Just hit the subscribe button. And if you have any stories to share of like how you've messed up, or any of your horror stories of racking up a bill or even bringing production down, whatever the case might be, tell us a story or two in the comments. Would love to hear it. And as well, this entire talk is available as a blog post in the comments. Sorry, in the description as well. Nonetheless, this has been fun, and I'll check everybody in the next video. Cheers.